rovers can't do it.
ARES is an acronym for Aerial Regional Scale Environmental Surveyor. And getting it to the Red Planet will be a wild ride.
Main engine start and switch on.
We fly ARES to Mars in a spacecraft. It's in something called an aeroshell. An aeroshell is like a big garbage can.
But in order to fit the aeroshell into the spacecraft, it must be less than 3 meters across, much smaller than the plane, which is more than 5 meters long and has a wingspan nearly 6.5 meters.
It's a pretty large airplane. So the question is, how do you get an airplane in a garbage can or aeroshell? And that's been the major problem, how to package the airplane so we can get it to Mars. So what we've decided to do is fold the airplane. We fold the right wing, we fold the left wing, we fold the tail over the body of the plane.
The folded plane is packed inside the aeroshell and put in the spacecraft. This payload will then be launched into space on a Delta rocket. The journey is long, more than 100 million kilometers. It will take more than 6 months to get to the Red Planet.
As it approaches Mars, the aeroshell is jettisoned from the spacecraft. The aeroshell is attracted by the gravitational field of Mars.
The aeroshell has thermal tiles just like the space shuttle to protect it from the heat as it enters Mars' atmosphere.
On predetermined time, depending on the altitude, a parachute opens up.
The parachute slows the aeroshell down to about 160 kilometers per hour.
Then the bottom of the aeroshell is jettisoned, and for the first time the airplane, ARES, which is still folded, is exposed to the Mars atmosphere. The next thing that happens is a spring mechanism causes ARES to jettison or leave the aeroshell. The tail unfolds, then the right wing unfolds, then the left wing unfolds, then the rocket engine begins, and it starts its historic flight through the atmosphere of Mars.
But there are some engineering issues to overcome when making an airplane that will fly on Mars, where the atmosphere is less than 1% the thickness of Earth's atmosphere.
The airplane was designed in such a way the wing has a very large area because, as you know, the wing gives the airplane the lift. In the very thin atmosphere of Mars, there are less molecules per unit volume. So mathematics comes into designing the plane to design this big area wing, to design the curvature of the wing or the airfoil to give us maximum lift in the thin atmosphere of Mars.
To prepare for the mission, ARES has undergone lots of testing, not only in the wind tunnels of NASA Langley Research Center, but also at 38 kilometers, or about 125,000 feet, above Tillamook, Oregon.
We put the airplane folded up the way it will fly to Mars on a helium balloon at 125,000 feet. The density of the atmosphere and the pressure of the atmosphere is much less. It's like the Mars atmosphere in the region that will fly. We deploy it, we release it from the balloon, the tail unfolds, the wing unfolds, and it begins its flight. At that altitude, the sky is black, and you actually see the curvature of the Earth.
These images were captured by one of the plane's onboard cameras. Just imagine what those cameras will see when they get to Mars. They will give us views of the planet like no one has ever seen before.
The camera on ARES is a high-resolution camera, and because we're only flying a mile above the surface, we can measure details on the surface of Mars, rocks and sand and so on. In fact, if there was a candy wrapper on the surface of Mars, we could read the name and where it was made and the ingredients in the candy.
Another instrument on ARES could answer one of the oldest questions about the Red Planet. Is there life on Mars?
One of the most interesting experiments that we carry is called a mass spectrometer. Now, what a mass spectrometer does is it brings in a sample of the Mars atmosphere, and in 3 minutes, it analyzes the chemical composition of the gas mixture of the Mars atmosphere. It measures dozens of gases and the concentration.
It's looking for gases like methane, ammonia, and nitrous oxide.
These gases are produced by metabolic processes in living systems, from humans to microorganisms. So there is a unique class of gases, we call them biogenic gases, that are only produced by life. And if we detect these gases, it's an indication that they may be due to living systems on Mars.
That's pretty awesome. And so is this. One of the coolest things about ARES is that NASA is taking us along for the ride.
As we fly through the atmosphere of Mars, we will transmit these images back to Earth in real time. We will bring the United States, in fact the world, along with us.
Until then, you can take ARES for a virtual test flight.
Just go to marsairplane.lark.nasa.gov. Click on Multimedia, and then download this really cool Mars Flight Interactive Simulator.
Then you can operate the ARES Scout right from your computer. Gotta fly. I'll see you on Mars.